Okay, in this example, what I want to go over is how we could take and write a program that's going to find what's called palindromic phrases, not just a palindromic word. And what I mean by phrase is that we're not just seeing if the word itself is reversed, is we're taking two words together and seeing that if you reverse that particular word, or that phrase, that it will also be a palindrome. So, as an example, if I were to take, say, fear and put it together with serious, I'm going to get this word fear serious. But if I were to go in and take the reverse of this, I'm going to get this phrase in reverse. And obviously, we can see that this is not a palindromic phrase. So, what I want you to do, or what we're going to discuss, which is going to help you with a later project, is I want you to write a program that's going to take these 30 words and put them together, and see that if there's some combination you can put them together such when you put the words together, when you reverse that phrase, you get the phrase that you started out with. And so, you could go in, and because you have 30 words, you could have up to a 30 word combination where you have like fear, serious, carry, stop, all into one particular phrase. The problem is that's going to become very computationally intensive. So for this example, I'm just going to ask you to put together 4 words and make a phrase out of that. Because the purpose of this is to learn how to do it and to learn kind of a logical thinking and a procedural thinking and programming. So it's not just to see if they actually exist, because other people have actually already, done that. So what we're going to do in this particular case is we're just going to have 4 nested loops. So because we have 30 words, our first loop is just going to start out with 1 to 30. And I just choose A, B, C, and D because they're the first 4 letters instead of like I, J, K, L, and M. But you could choose anything you wanted. So I just have 4 nested loops here. 4 equal A 1 to 30, B 1 to 30, all the way down to D 1 to 30. And then I create this new variable, what I called word pal, and it's just basically concatenating the 4 words together. So when you just put this and symbol, it just stitches them together, just like what I showed you. If I were to take room and then and challenge, it's just going to put them together. And and then, if I come down here and use this reverse command that we had written, and then take it of the original word, it's going to reverse that. And one thing that I did here is I have this statement in here, and what this does is kind of reduce the number of iterations that you have to go through. It just looks at the left letter of your new phrase and the rightmost letter of your new phrase. So the leftmost letter is R, the rightmost letter is E, and it says, if these two are equal to one another, then I'm going to reverse the word. And the reason why I do that is because it saves cycles. Because if you don't have that, what it'll do, let's suppose you just got rid of this statement right here, it's going to reverse every word. And if you look at your reverse function, this is an iterative loop. So, if you have a phrase that's like 30 letters long, you have to go through and cycle through 30 times just in this reverse function. So this reverse function isn't free in the sense that it does require iterations. And this is just like a very first cut. If the first and last letters of the phrase aren't equal, then obviously you don't have to go in and look to see if it's a palindrome, because by definition it's not a palindrome. So R isn't equal to E. So you could then even have the argument, well, why couldn't we look at the second letter and the third letter? And the answer is you could. You could actually write a subroutine to search for a palindrome that way, and it may actually be more efficient than the way that I'm teaching you. I kind of want to double down on this approach because we spent so much time writing the reverse function and me explaining what it is. But it's really up to you if you can come up with a better way. Many of the programs I show you how to do are just kind of how I do them. They're not necessarily optimized because this is a course to teach you how to do things and to teach you about functions and procedures and that sort of thing. So I'm not necessarily writing all my programs in the most optimal manner. I'm writing them in a way so you can learn how to program. But if you feel like that you could come up with a better way of doing this, that's fine also. So the way I approach this is now I create a new variable which I call pal for just palindrome, and it just simply takes the reverse of the original word that we have. And then I just say, if word pal, which is the original word, is equal to pal, then I'm going to add one to my counter, and then I'm going to come over here, 4 columns over just in my D column, and I just pick that because it's kind of far away from my original word so I can see what the answer is. And I'm just going to simply record that, and then I'm going to debug.print, which will put the answer down here in the immediate window. If you don't have the immediate window, just go up here under view and click on immediate window, and it will bring this up. So it's just a way to kind of put an output so you can kind of see what's going on with your program. And then you just end that statement, and then I just go through the next cycles. And you may say, well, what is this debug print? All this is doing is keeping track of kind of my status. Um, you know, at each, not at each iteration, because if it was at each iteration, I would put it here. Um, but what happens is every time you have this debug print, it slows your computer down. So I'm only using this so we can watch the program actually run. Okay, this is not a necessary statement. So let's just go in and run it, and then once we get the answer, I will discuss what's actually going on. Okay, so let's just go ahead and run this. So I'm just going to hit run, and here we go. And we can see that this is actually running for us. And what happens is that just Excel's not the best program in the world when it comes to displaying it because it's so graphically intensive. Sometimes it'll lock up, and it's actually running in the background, and you can see the answers are kind of popping out over here, but it's not really updating. And this is just a feature of Excel. It's not really made to run, I'll say, very computationally intensive things. It can, but that's not its true purpose. But anyway, it went through all the iterations, and we can see here are the answers that we have. So you look at this, and it's like we have 1, 2, 3, 4, 5, 6, 7 palindrome that came from this list of words. Now, some of these aren't really interesting. So if you look at this, while this is technically a palindrome, live, live, evil, evil, that's not really what I'm looking for. So I'm just going to delete this one. Live not on evil. Those are 4 unique words, so I'm kind of interested in this one. This one is live evil, live evil. That one's kind of boring. This one's what? Not on, no, not, not on, not on. That one's kind of boring. This one looks boring. Evil, not on, live. That one doesn't really make sense. And this one's just evil, evil, live, live. So I'm going to just manually delete those. So this is the one that I was really interested in. This was my intention when I put these words together to get this palindrome. Live not on evil. And that's what I was looking for. So sometimes you'll get palindromes, even though technically they're palindromes, they're just kind of boring. Let's suppose that I had the letter A or I down here, then I'm just going to get like 4 A's or 4 I's. So it's a palindrome, but it's not really a phrase. So that's kind of what I want you to be aware of. And if I give you an assignment, I'll tell you specifically what I'm looking for. But let's go ahead and let's comment this out real quick, and let's just observe just how much quicker that this actually ran. So if I run this now, just watch how much quicker it is because we're not actually displaying an output. So, we're already down to 3 of them that it's found, 4, and it's running in the background, and it's already found all of them, so we're done. So, I mean, that sped this up by a factor of what, maybe 10? I didn't really keep track. But like I said, the only reason why I put this in was just so we could see real time how it was counting, but it does nothing for the actual program itself. So I just wanted to share this program with you. I think it's going to help you out with your final project and kind of what I'm looking for. And that's really all there is to it.